Classwork 17. That's the first question. After riding a bicycle at a steady speed for 40 miles distance, we're still going to use the distance formula. John had a flat tire and walked 5 miles to a repair shop. So when he bicycles, his cycling rate, which is his speed, was 4 times faster than his walking speed. So if the time spent cycling and walking together was 5 hours, at what rate was his, when he was his speed when he bicycling? I don't like how those words here, but anyway. So basically, he bicycled, he walked, right? So because we're looking for the speed, rate, whenever we see rate of change, the speed of doing something. So let's call the bicycling speed B. Let's call the walking speed W. Okay. So if the time spent cycling and walking was 5 hours, so the total time was 5 hours. Okay, let's write down equals to 5 hours. So we need to figure out the time used for bicycling. So bicycling time and time for walking. Add together, that's 5. So time for bicycling, remember T equals to distance divided by speed, right? So he bicycled 40 miles. What is his speed of bicycling? We don't know, and we call the B, right? And this walking, how many miles he walked? He walked 5 miles. What's his speed of walking? We don't know, and we call W, right? So this is time spent on bicycling. This is time spent on walking. Distance divided by speed. What else we know? We know the relationship between the two speeds. So his bicycling speed was 4 times faster than his walking. So that's saying bicycling speed is 4 times of his walking. So we have made system equations. To solve this, we just change this B. We just change this B into 4W, right? Into 4W. Now we only have one variable for the first equation. So basically we use the second equation. We substitute B into 4W. Now we multiply 4 over 4, multiply 1 for this because we need a common denominator. Then we have numerator, we have 40 plus 5 times 4, 20, divided by 4W, the common denominator, that equals to 5. 40 plus 20, of course, 60, right? Divided by 4W equals to 5. Can we simplify 60 and 4? Sure. 4 goes into 60 15 times, right? 15 times 4, that's 60. So that means that, so we have 15 over W equals to 5. We multiply W on both sides. This W cancel this W, so we get 15 equals to 5W. So that divided by 5 on both sides, W equals to 3. So his walking speed is 3 miles per hour. And his bicycling speed is 4 times of his walking speed. So that's equal to 12 miles per hour. Okay, so what did we do? We use, because we know, so the bicycling and the walking time total together is 5 hours. So we figure out the time he spent bicycling, which is he bicycled 40 miles divided by its speed. We don't know his speed, we call it B. At the time walking, he walked 5 miles, and we don't know his speed, we call W. Then we know his bicycling speed is 4 times faster than his walking. So which means B equals 4W. Then we change this B to be 4W. We make it common denominators, then we just solve. So we got a walking speed is 3 miles per hour, and the bicycling speed is 12 miles per hour. Let's see 2. A pool can be filled by one pipe in 8 hours, a second pipe in 24 hours. How long will it take using both pipes to fill the pool? Well, let's see T times. It would take T hours, for the 2 pipes to work at the same time. All right. So remember, when 2 pipes working together, so we add up their speed, right? So what is the speed of working together? That's 1 over T, right? Work done divided by the time it need, that's 1 over T. Then that is the speed of the first pipe, 1 over 8 hours, plus the speed of a second pipe, which is 1 over 24. Right? Now we combine this, which is multiplied. We need a common denominator. So this becomes 3 plus 1 over 24, right? Which is 4 over 24. Or that can be simplified as 1 over 6, because 4 goes into 24 6 times. So 1 over T equals to 1 over 6. So we flip over, so T equals to 6. So it would take 6 hours for the both pipe together to fill the pool. Right? It's much faster than the first pipe work by itself or second pipe work by itself. Now let's see 3. Y varies inversely with X. So right away, we think about the formula is Y equals to K divided by X, or K equals to X times Y. So now see, when Y is 8, X is 5. So when Y is 8, X is 5. So that means K equals to 8 times 5, which is 40. So that means X times Y equals to 40. So K is a constant. Okay, XY equals to 40. Now, finding Y when X is 2. Finding Y when X is 2. So 2Y equals to 40. Divided by 2, so Y equals to 20. What did we do? So we recall the formula of varies inversely. Either we use Y equals K over X, or we use the constant K equals XY. Doesn't matter which one. And we're given Y is 8, X is 5. So X is 8, Y is 8, X is 5. So we got a K equals multiply those to get 40. So that means we have a specific equation, X times Y equals 40. The question is asking, what is Y when X is 2? So we got 2Y equals 40, so Y equals 20. Let's see 4 and 5. 4 is saying the number of gallons of water W used when taking a shower varies directly as the time T. So right away, we write our formula. The W equals to varies directly, that's some constant K times T in minutes in the shower. So a shower lasting 6 minutes, right? A shower lasting 6 minutes will use 30 gallons of water. So we have this equation. So we divide by 6 on both sides, K equals to 5. So that means W equals to 5 times T. So how much water is used? How much water is used in 11 minutes? Substitute 11 with T. 5 times 11, so 55 gallons. Okay, so varies directly is W equals KT between those two variables. Think W as Y, T as X. Okay, then try to put the value, the data given into right spots. So 6 is time, so we substitute T. 30 gallons is water, we substitute W. Okay, then out of this relation, we get a K constant equals 5. So we get a specific formula, W equals 5T in this case. Then to answer the question, how much water is used in the shower lasting 11 minutes? So W, shower in gallons, equals to 5, the constant K, multiply 11 minutes, which is 55 gallons. Now let's see 5. When the temperature stays the same, the volume of gas is inversely proportional. Inversely proportional means inverse direction, variation to the pressure of the gas. Okay, let's call this temperature T. Let's call the pressure P. So this is given as a T equals to some constant K divided by P, by the pressure, K divided by the pressure. Or K equals the temperature multiplied by the pressure. If a gallon is filled with 228 cubic inches of gas, right, at a pressure of 14 pounds per square inch, this is a cubic. If a balloon is filled with 208 cubic inches, so that's a volume. So volume equal to 228 cubic inches, inch cube, 3-dimension quantity of a gas at a pressure of 14. Oh, sorry, we don't need a T here. We need the volume of gas. So we use capital V, volume. This is not T, this is volume. We don't need a time. So when the balloon is filled with 228, that means this is 228, this V. We don't know K. And the pressure is 14, which is multiply those two. So this is our K, 228 times 14. I don't want to multiply them out because I'm hoping in the future I can perform some consolations. So the question is, find the new pressure of the gas, find the P, right? If the volume is decreased to 38 cubic inches, so what do you call it? The volume is decreased to 38 cubic inches. So the volume, when the volume is 38, the pressure we don't know, but we know K is 228 multiplied by 14. Right, we have formed this. K equals to V, the volume, multiplied by its pressure. So now let's divide 38 on both sides. How do we do that? Well, first let's divide by 2. 38 divided by 2 get 19. Okay. 238 divided by 2 get a 114. Can 114, does 114 divide 19? Let's try. 114 divided by 19. Maybe 6. 6 times 9, 54, right? Carry 5. Then 1 times 6, 6. 6 plus 5, 11. Bingo. All right. So 114 is 6 times 19. So 19 cancels with 19. So left with 6. So 6 times 14. So pressure P equals to 6 times 14, which is 6 times 4, 24, carry 2. 1 times 6, 6 plus 2, 84. So when the volume is 38 cubic inches, the gas pressure is 84. Okay, 84 pounds per square inch. And that's it. This is varies inversely. We just pick different formulas to apply.